Alrighty, hey everyone. So in this video we're going to be talking about multiplication again. Hopefully you guys understood everything from the last video, but if you didn't, then you can always go back and watch that before you get started on your assignment. So just as a brief rundown, what we did before was we were doing long multiplication, where you take a number like this, for instance, and you start by just taking the number in the ones column here and multiplying it by each digit up top, and then doing the same thing with the second number down here, and then adding those two results. So just really quickly, this example, you get 5 times 3 is 15, carry the 1, 5 times 2 is 10, plus 1 is 11, 5 times 1 is 5, plus 1 is 6, and then in the second row, in the second row down here, you do the same thing but with the 4. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. So you would get 5 at the bottom, 3, 9 plus 6 is 15, and a 5. So you'd get something like that. Hopefully I didn't make a mistake there. But yeah, just that's a really brief rundown of long multiplication. You can go back and rewatch that lesson if you get stuck when it comes time for your assignment. But what we're going to cover today is something a little bit different. This is called lattice multiplication. So it's just a different way to multiply numbers. Lattice multiplication. Alright, so the way this is going to work is I'm going to just go through a few examples and sort of explain how it works. And in one of them I will do the same example, or I'll use the same numbers as one of the long multiplication things, just so you can see that it does give the same end result. So I've got my worked out solutions here, just so that I can confirm that my answers are correct, because I don't want to be doing this wrong. But yeah, this is a new thing that I learned very recently, and I wanted to show you guys because some people do find this method a lot easier. So let's say you wanted to multiply the numbers 634 and 57. Alright, so the way you're going to do this is you're going to set it up so that you have, you're going to write 634 like this across the top, and you're going to make a line there, and you're going to use that to actually build a box. And you're going to put a 57 down the side over there, and you're going to make your box like so. Something like that. That's going to be a little slanted, I'm sure, but hopefully you get the idea. So basically, the number of columns you have, that's the vertical ones, so the number of columns you have is just the number of digits you have in this first number. So we've got 634, so there's going to be 3 columns, and then the number of digits you have in the second number will tell you how many rows you have. That's the horizontal one. So we've got 1, 2, because we've got the 5 and the 7, so we've got 1, 2 rows. Now, here's the key part. You have to make diagonal lines, and you have to make sure that these go in the right direction, or else it'll mess up the whole problem. So you have to go from the top right to the bottom left, and extend it out past the end of the box. So when you're drawing these in your notebooks, try and draw the same box that I've got going here. Alright, something like that. And I think you are allowed to stop there. You don't have to add like little extra ticks on the end. I like to put one down here. That's just, since I learned how to do it, it just looked a little empty in this bottom corner without one. If you really want, you could also put one up top there, but I don't think those two ones on the end matter very much, just as long as these are going in the right direction. So basically the way this works is you're going to multiply each digit up here by each digit down there, over on the side, and for the answer you're going to put the number that's in the ones place over in the lower box, and the number that's in the tens place up in the higher box. So for example, 4 times 5, right here, we've got the 4 times 5. 4 times 5 is 20. That's an E, not an equal sign. 4 times 5 is 20. So because we've got the 2 in the tens place, the 2 will go right here, and we've got a 0 in the ones place, so the 0 will go down there. Alright, so we're going to do that same process for all of these other numbers. And I guess the beauty of this system is that you can kind of jump around wherever you want. We could do 6 times 7 next if we wanted to, or we can go, column by column. We can go right to left, we can go left to right, down, up, down, anything we want we can do with this system. So we've got 4 times 5 is 20. I'm just going to go column by column, and I'll start from the right and then work my way left. Hopefully I'll stay consistent with that, but you don't have to do it that way. You could do it going this way, right to left. As long as all the numbers in the boxes are correct, it doesn't matter the order that you do it in. So we've got 4 times 5 is 20. Now 4 times 7 is 28. So the number in the tens place is the 2, 20. So you'll have the 2 there, and then the 8 goes down there. So you can see that we're building those numbers. Hopefully you guys can see this all right. I hope it's not too dark. But yeah, so we've got the 20 and the 28 from 4 times 5 and 4 times 7, respectively. Now we do the same thing with 3. So we do 3 times 5, which is 15. So we put the 1 up there and the 5 down there. And then we do 3 times 7. So we put the 2 up there and the 1 down there for 21. 3 times 7 is 21. So now we've done the 4s and the 3s, we just have to do the 6s now. So we do 6 times 5, which is 30, and that'll go over here with the 3 in the tens place, so it gets the higher box, it goes upstairs, and the 0 goes downstairs, if you will. And then the last one is 6 times 7, which is 42, so we put the 4 there and the 2 there. So now we're almost finished. At this point, what you want to do is you're going to add the numbers going along each diagonal. Okay, so we're not adding them this way, the way we normally would for long multiplication. Everything is in columns. So we do have columns, but we're not adding by the columns. We're going to add along the diagonals. So you're going to have to watch carefully because it looks a little bit wonky for, if you've been taught addition, that you make everything in neat columns and then you carry the 1 into the next column. It's a little bit wonky when you make it diagonal, so you'll have to be a little bit careful. So this 8 right here is sitting by itself, so we can just put that down here. Now we've got here along this column, we've got 2 plus 1, so that's 3, so we put that there. Alright, now here we've got 5 plus 2, which is 7, plus 2, which is 9, plus 2, which is 11. Alright, so normally with addition you would put the 1 down here and then carry the 1 to the next column, but since we're not working with columns, we're working with diagonals. We've got 2 plus 5 is 7, plus 2 is 9, plus 2 is 11, so we put the 1 from the 1's place down here, and we carry the other one up there into the next diagonal. So hopefully you saw that. So here is the one where we got our 11, so the second number 1 from 11 goes down here, and the first one gets carried into the next column. Right? So we went from this column, shifted over to the next one, and carried the 1 there. Now we can add this one, so this will just be another addition. So we do 1 plus 1 is 2, plus 4 is 6, and then this 3 sits by itself. Alright, so now we've got these numbers on the outside. We've got 3, 6, 1, 3, and 8, and that's actually your answer. You just read from up here, down and around in that direction, and you'll get your answer. So you can get that your final answer to this is 36,138. That's just by reading from up here in the top left, down and around to the bottom right. So you just read off those numbers, and that'll give you your answer. So hopefully that makes sense. I'm going to do a second example now. It's going to be similar, but I'm going to actually use the same numbers as one of the previous examples that we did with long multiplication, just so you gain some confidence that this gives you the right answer. And it'll be a slightly larger number, so the box will be a little bit bigger, and that'll give you guys some practice working with this. So we're going to do the example that we did last time, which is 9,062 multiplied by 54. Okay, so we're going to build our box. So we're going to start by putting our, we can even make the box first if you wish, so let's do it that way this time. We'll make the box first. I don't need that much, that looks like a flag. I'll put this going across. The only thing you have to be careful about if you do make the box first is that you make it big enough to have all the numbers you want. Like if this was going to be like a 7-digit number at the top, then I would want this box to be a lot wider than it is right now. So you've got to be careful of that if you do make the box first. And then we're going to have these diagonals going here. They might not line up perfectly with the corners, but as long as you can kind of see where it's going, then hopefully that's good enough. And we'll put the numbers in now. So we've got 9,062 multiplied by 54. Alright, so the target answer, the one we got before, I'll give you that now just so we can see if it matches. The one we got before is 489,348. So that's our target. That's the number that we want to get this time. And if we get the same answer, then we can have confidence that this works just as well as long multiplication. So let's go through it, and we'll start by doing 2 times 5. We'll just do this first column, and then we'll move over column by column until we get to this last one. So first we do 2 times 5, which equals 10. So from 10, we take this 1 that's in the tens place, and we're going to put it over here. And we're going to take the 0 in the ones place and put it down there. And we're going to repeat this process for all the numbers. If your answer is a single digit, then the number in your tens place will just be a 0. So 2 times 4 is 8, so you only put an 8 in the ones place, and you can put a 0 upstairs. Now we do 6 times 5, which is 30. So we put the 3 in the tens place, and we do 6 times 4, which is 24. So that's going to go down here. Now we move over to the 0 here, and that is just, it just makes life easy. 0 times anything is 0, so we can just fill this whole column with zeros. 0 times 5 is 0, so I put 2 zeros there, and 0 times 4 is 0, so you put 2 more zeros there. And now we just have 2 left, 9 times 5 and 9 times 4. So let's do 9 times 5 first. That's going to give us 45. So we put that there, 4 in the tens place, 5 in the ones place. And then we do 9 times 4, which is 36. So that's going to go down there, 3 in the tens place and 6 in the ones place. Right, so hopefully that's making sense, and hopefully it's big enough that you guys can see it and bright enough that you can see it. And now all we really have to do is just add along the diagonals, and for that you always want to start over here on the right. So when you're filling in these boxes, you can do that from wherever, but when you're building your final answer by adding, always start from the right end, just the way you normally would with addition. So this 8 can just sit by itself. So it's good that we have an 8 because that matches that last digit over there. We just want to see if the rest of them match. So then we've got 4 plus 0 plus 0, so the 4 sits there, and that also matches. Now we've got 2 plus 1, which is 3, in this third diagonal right here, and that matches that as well. Then we've got 3 plus 6 is 9, which matches that. Then we've got 5 plus 3, which is 8, which matches the one up there. And then lastly, we've got this 4 sitting by itself, which matches that right there. So if you just read your answer from up here, down and around to over there, you get 489,348 as your final answer, which matches what we got in long multiplication. So hopefully this gives you guys the confidence that this isn't just some made-up system that only works some of the time. We picked these numbers at random before, and it works just as well now. Of course, with this problem, we made things a little bit easier by having a 0 and just filling in all of those boxes. It's kind of zeros all over the place, so that made this one a little bit easier than others might be. So what we'll do now is I'll do 2 more examples. One just for you guys to see a little bit more for practice, and then we'll do one with a slightly longer number. So the next one we'll do is 881 multiplied by 19. Yes. Alright, so I'm going to build my box. Yeah, I apologize about the lighting situation here. I'm going to try and find a better way to make these. But for now, I'm going to just try and use the darkest markers that I have so that you guys can see this as clearly as possible. Alright, so now we've got to put our numbers in. So we put 881 times 19, and we go from there. So 1 times 1 is 1, so we leave a 0 in the tens place, and we put a 1 down there. And we do 1 times 9 is 9, so 0 in the tens place, and a 9 down there. Then we do 8 times 1 is 8. Same thing. 8 times 9 is 72, so we put that there. And you can recalculate it for this last one, but because it's an 8, and we just did an 8, you could just copy those boxes, but we'll do it again. So 8 times 1 is 8, so we put a 0 in the tens place, 8 in the ones place. 8 times 9 is 72, so 7 in the tens place, and 2 in the ones place. And now we just have to add along the diagonals again, and then we'll be finished. So it takes a little bit of work to build the boxes, but once you really get going, there's not that much to it. So you leave this 9 as it is. 2 plus 1 is 3, so that's going to go right there. 8 plus 7 is 15, plus 2 is 17, so we're going to have a 7. 8 plus 7 is 15, plus 1 is 16. Make sure you don't forget whatever you carry up there. And then 0 plus 1 is just 1. So we get 1, 6, 7, 3, 9. Does that match? That does match. So we get a final answer of 16,739. So hopefully that makes sense. And if you've made a mistake and you can't quite figure it out, see where your numbers disagree with these. And if you want, check a calculator to make sure that I've done it right. I've now done it twice, but I could have made the same mistake twice. So double check this if you are getting a different answer, but if you're getting the same answer, then all is well. I also checked this on a calculator myself, so I'm fairly confident that this is correct. So the last one we're going to do is slightly longer, in the sense that we're doing a 4-digit number by a 4-digit number, so the box is going to be quite large. So the numbers are 9,630 times 2,468. So 9630 times 2468, just two numerical patterns there, and we're just multiplying those together. So we're going to have to build a fairly large box. Or you could just build a regular size box, and then the squares will have to be really small inside. So I'm going to try to make this as evenly sized as possible. When I was making my notes for these, I had all the boxes were like really wide rectangles like this, but I'd prefer them to be squares just like for myself. If you prefer making them really, really wide, then you can do that. I'll show you what I mean. Here's what the squares in my notes look like. Don't try and read the numbers. I'm just showing you that they're really, really wide boxes. But I think for me it's just easier on the eye if they're all squares like this. So we make our squares like so. And because it's a 4-digit number by a 4-digit number, this is going to be fairly large. And we've got a lot of rows to fill in here. Right, so we've got to... What am I doing? That doesn't make any sense. I have not lined this up very well at all. So that goes there. And then that's supposed to go over there. Yeah, my apologies. This is not the best way I could have drawn it, but oops. Hopefully this is still making sense. So we put the first number, I put across the top, so 9, 6, 3, 0, and then we put 2, 4, 6, 8 down the side. Since they have the same number of digits, you could have put them in the other spot, but you just need to make sure that the number of digits matches the columns and matches the rows. You don't want to have a 4-digit number but only 3 columns, because that's not going to work. But here, since they've got the same number of digits, you can do whatever you please. So over here, we'll start on the right as usual, and we start off fairly easy because we've got a 0 at the top, so 0 times any of these things is still going to be a 0. So we just fill in this whole thing with zeros. 0 times 2 is 0, 0 times 4 is 0, 0 times 6 is 0, and 0 times 8 is 0. So we've got a whole bunch of zeros there. Now we do 3 times 2, which is 6. So that's a 0 in the tens column, and then a 6 in the ones column. Then we do 3 times 4 is 12. So that goes there. 3 times 6 is 18. So you're going to have to line those up there. 1 in the tens place, 8 in the ones place. And 3 times 8 is 24. So the 2 goes upstairs, the 4 goes downstairs. Now we do the same thing with the 6. 6 times 2 is 12. 6 times 4 is 24. 6 times 6 is 36. And 6 times 8 is 48. With this problem, because they're all such nice patterns within the digits, you can tell you're doing it right if you see the pattern as you go down. 6, 12, 18, 14, 18, 24, counting by 6 is there. 12, 24, 36, 48, counting by 12s there. So if you can see those patterns as well in these numbers that where the digits have patterns in them, then you'll know you're doing it right as well. So then the last one we got is 9 times 2 is 18. 9 times 4 is 36. 9 times 6 is 54. And 9 times 8 is 72. So we write them like so. Alright, so hopefully that's making sense. So now all that's left is just to add these. And we start from that bottom corner over there. So 0 sits by itself. And we've got 4 plus 0 plus 0, so that's going to be 4. And we've got 8 plus 2 is 10, plus 8 is 18. So we put an 8, and we carry the 1 into this diagonal. So I'm just going to put it up there. Just make sure you don't forget about it once you put it up there. Find a way, maybe put a circle around it or something. Find a way to make sure that you don't forget that you've carried a number there. Maybe start from that corner. So you do 1 plus 2 is 3, plus 1 is 4, plus 6 is 10, plus 4 is 14, plus 2 is 16. So you put 6 down here, carry the 1, and then you can count from up there again. 1 plus 6 is 7, plus 1 is 8, plus 4 is 12, plus 3 is 15, plus 4 is 19, plus 7 is 26. So we put a 6 there, carry the 2. 2 plus 2 is 4, plus 2 is 6, 6 plus 6 is 12, and 12 plus 5 is 17. Carry the 1. 1 plus 1 is 2, 2 plus 8 is 10, plus 3 is 13. Carry the 1, 1 plus 1 is 2. So we get 2, 3, 7, 6, 6, 8, 4, 0. So that would be 23,766,840. So you can write that all out, just starting from the top left and then going down and around. So you get 23,766,840. Does that match what I got earlier? 2, 3, 7, 6, 6, 8, 4, 0. Yes, it does. Now, if you prefer to put spaces or commas to separate your thousands from your hundreds and your millions from your billions and all of that, then do whatever's easiest for you. In Canada, people tend to use spaces. In the United States, people tend to use commas. in other languages. Sometimes they use dots, so it can really be whatever you want as long as you understand it and whoever is marking your assignments and tests understands what you're doing. I've put commas now just because I don't really have enough room to put spaces without sort of squishing it towards the end, so I ignored spaces and put commas there just for this particular case. But yeah, so that's lattice multiplication. It gets a little bit long for bigger numbers. There are definitely positives to using this one, and there are positives to using long multiplication, but I'd say just practice a little bit of both, especially on your assignment. If you're more comfortable with one, try the other. So your assignment number 1 is purely multiplication, and if you're feeling really comfortable with long multiplication, try doing this a few times or try both of them and see if it gives you the same answer, because there are times where this one might be easier. It's a little bit more tedious if you're not used to it, so for me I would naturally choose long multiplication, but it's good to practice both. But at the end of the day, just go with what you're comfortable with, but do try the other one a little bit if you're finding it too easy the way you know. So that's all for this video. Good luck on your assignment. You guys will have my contact information on the assignment, so if you get in trouble working on that, then you can send me an email. Otherwise, I will see you guys in the next video. Have a good weekend.